In lesson 2, we're going to introduce radian measure. So just as an example, if we had a pendulum with a long arm TA, and the pendulum's going to swing one full cycle, it would swing from this position all the way across and then all the way back, and that would be one cycle. If we're talking about P being the perpendicular distance from T to B, P on this side is going to be greater than 0, and P on this side is going to be less than 0. And this takes time for this one swing. So if we were going to imagine what that would look like on a graph, it does say it takes 6.2 seconds to complete one cycle. So when we look at this graph, it kind of looks like the cosine function. But when we graphed our cosine function, we started at 1. It had a maximum of 1 and a minimum of -1. But one cycle, we had degrees across here on our x-axis. This is showing that perhaps time could be on the x-axis. So graphing functions like this, these periodic functions, it's not necessarily true that there's always an angle measurement across the x-axis. So for example here, it takes 6.2 seconds to complete one cycle. So this example is just to kind of point out that for many problems in applied trigonometry, angles measured in degrees are acceptable. But sometimes when we're looking at analytical trigonometry, it's more convenient to introduce a different unit of angle measurement. This is called a radian. So I'm going to try and explain what a radian is, and then in our next lesson as well, we'll go over it a little bit more. If we're looking at a unit of measure that is 1 radian, a radian is the measure of an angle subtended at the center of the circle by an arc equal in length to the radius of the circle. So what I mean by that, this diagram's a little bit better. If we had a radius length that is r, and we have this arc length here that is actually the same measurement as the radius, and they equal each other. So the length of AB is the same as the length of the radius. This is called 1 radian measure. So another way to think about that, if we had an angle that was 360 degrees, so what if our angle was 360 degrees? So that would mean this would be our radius here, and our angle would start here and go all the way around like that. That would be our angle measurement. That would be 360 degrees in one full rotation. So what does that mean? Well, the length of the arc that subtends the circle, that word subtends just means the length of the arc for that particular angle measurement. If we're talking about an entire 360 degrees, that would be 2 pi r, because that is the circumference of a circle. So if we think about 2 pi radians equaling 360 degrees, what we're talking about is one full rotation around the entire circle would be 2 pi radians. So what we could do, we could divide both sides by 2. And so what that means is that pi radians equal 180 degrees. And therefore we can say that 1 radian, if I divide both sides by pi, 1 radian is equal to 180 degrees divided by pi. So this is a formula that we need to know. 1 radian equals 180 degrees divided by pi. The magnitude of a radian is independent of r, and it is the same for all circles. So this also establishes the relationship between radians and degrees. If we go back to where we were up here and we continue on from there, pi radians equals 180 degrees. 1 radian equals 180 over pi. If I rearrange this, pi comes up here and 180 could go down there, and then we divide. We can also figure out that 1 degree equals pi divided by 180 radians. So something that I just want to sketch for you before we move on, this is what we'll talk about more in our next lesson. But imagine coming all the way around the circle. That would be 2 pi radians. That is 360 degrees. If we only went 180 degrees and we ended over here, so if I did another angle that just was 180 degrees, that would be equal to pi radians. Using these relations, it's easy to convert from one measure to the other. So these are our two formulas that we really need to use, and we'll do an example and practice this. In, in recording angle measures in radians, we often use abbreviations like rad for radians, and that is actually on your scientific calculator. You might remember saying, oh my gosh, make sure your calculator's in degrees. Sometimes it might be in radians, and you're getting a different answer than we are when our calculators are in degrees. We can refer to an angle of 0.4 radians, or we could call that 0.4 rad, or just a little superscript here that is a little tiny r for radians. You might see any of those notations. So if we just do a little practice with this, and I think it'll make a lot more sense even with the next lesson that we do. But in order to get degrees to radians, we have a little formula. 1 degree equals pi over 180 radians. So 30 degrees is going to equal 30 pi over 180 radians. All we can really do is just reduce this, and we can divide both by 30, so we would just get 1 pi, and then 180 divided by 30 is 6. So pi over 6 radians. So 30 degrees equals pi over 6 radians. How that might relate to our circle, if we imagine dividing pi into 6 equal sections like that, 1, 2, 3, 4, 5, 6, we're saying that 30 degrees is one of those pi over 6 radians. 246 degrees convert to radians, so 246 degrees equals 246 pi over 180 radians. So 246, what we can do there, we could divide by 6. The top and the bottom are divisible by 6, so we're just kind of trying to get lowest terms here. And that would be 41 pi over 30 radians. If we are going to go from radians to degrees, we had our little formula where 1 radian equals 180 over pi. So if we had 7 pi over 3, and you wouldn't have to write this out every time, but if we had 7 pi over 3 radians, that would equal 7 pi over 3 times 180 over pi. So we don't really have to write that out every time. What we end up doing is just 7 times 180 divided by 3. And so 7 pi over 3 radians is the same thing as 420 degrees. Negative pi over 3 radians. So if we had negative pi over 3, is the same thing as, we're going to just replace the pi with 180 degrees. So we get negative 60. And that might make sense as well. So if I'm thinking about pi, I don't know, we'll do more with this unit circle during our next lesson, but I'm trying to make this make a little bit of sense to you. So if we ignore this axis here, and we divide our pi 180 degrees into 3 sections, so imagine that one, so we've got 1, 2, 3 sections, negative 60 degrees. So if this was 60 and then 120 and then 180, negative 60 degrees is here, and that's why it's the same thing, this angle measurement there, that's why it's the same thing as 180 divided by 3, or negative 60 degrees. So use a calculator now to evaluate the following to 4 decimal places. Make sure you're in the correct mode. So when you notice here, this is not just saying tan 45 or tan sine 30. We have radian measurement here. So we have to make sure that our calculators are in radians. So maybe that just means there's a little R on your screen. You'd have to go to the mode on your calculator, and instead of degrees, you'd want to choose radians. So usually, I don't know what the button would look like, but you choose the mode, you make sure your calculator's in radians. And then we also want to use a lot of brackets when we type this in. So this is just typing this into your calculator, tan, bracket, pi, so hopefully you have a pi button on your calculator, pi divided by 10, and we get 0.3249. If we are in radians, we do sine, and then probably bracket, I'm thinking your calculator wants a bracket, sine 5 pi divided by 3, we get negative 0.8660. And here, since we're in radians, cos bracket 2 pi divided by 7 should give you 0.6235. So it would be good for you just to try that out on your calculator and see if you can get those same numbers.